write a power function whose graph passes through the points 27, 42, and 8, 24. Alright, a power function, what does that look like? Y equals A times x raised to the b power. Here with a power function, it's the variable that's the base instead of an exponent, unlike the exponential equation that we did in the previous video. Alright, so the way we solve it, though, is very similar. We're still going to stick in these 2 points that you're given and then set up a system of equations to solve by substitution. So for the first one, we'll plug in 42 for y. 42 is equal to a times 27 raised to the b power. Okay, and on the second one, we have 24 that's going in for y is equal to a times 8 to the b power. Now we need to choose one of these things to solve for a. It really doesn't matter which one, but I always choose the simpler one. In this case, it's the second one, and I'm going to solve it for a by dividing the 8 to the b over to the other side. So I have a is equal to 24, not 44, 24 divided by 8 to the b. And so I'm going to take that quantity for a, and I'm going to stick it into a in the first original equation. Okay, so I have 42 is equal to, I'm going to take the a out and put 24 divided by 8 to the b, all of this times 27 to the b. Alright, now on this one, this is a little tricky. We're going to use the power property of exponents backwards. Both this 8 and the 27 have a power of b, which means that originally it was like this. So let me write the 24. 24 didn't have anything to do with these two powers. In the parentheses, I have 27 up top, 8 on the bottom, all raised to the b. Right, it's kind of like factoring, except for with exponents. If I were to have used the power property with this fraction here, 27 over 8, raise it to the b, by the power property you're supposed to give that power to 27 and to 8, which is what the original problem was. Okay, so to further simplify this, let's divide by 24, and 42 over 24, I think simplifies to 1.75, is equal to 27 over 8 raised to the b. Now, since I'm trying to find a variable that is in the exponent, in order to solve it, I'm going to have to take the log of both sides. Let's just take the natural log of both sides. Natural log of the left side, nothing spectacular happens. It's just natural log of 1.75. And on the right-hand side, the b, the power, gets to come out by the power property b times the natural log of 27/8. Now, finally, to solve for b, we're just going to divide by the natural log of 27/8. So b is equal to the natural log of 1.75 divided by the natural log of 27/8. And it's at this point that you would put it into the calculator to approximate this, and you get about 0.46. Okay, and I would actually store that number in the calculator so we can get a more accurate number for a. So now we're going to take that 0.46, or actually the number that's stored in the calculator, and plug it in right up here so we can compute a. We've got 24 divided by 8 raised to our 0.46-ish power. Putting that into the calculator, we get approximately 9.22. Okay, so now approximating our equation, because these are both irrational numbers for our coefficient and for our exponent, we get about 9.22 times x raised to the 0.46 power.